Did you know that Boeing once planned to build a 3-engine version of the 747? Yes, a massive Trijet that could have changed the face of long-haul air travel forever. But strangely, they killed the project, quietly, almost secretly. Why? What happened inside Boeing's walls that made one of the boldest designs in aviation history vanish without a trace? In this video, we're digging deep into the untold story of Boeing's Trijet dream. You'll learn how fierce competition, hidden engineering challenges, and surprising aviation rules shaped its fate. We'll uncover secret design proposals, internal rivalries, and the real reason Boeing said no to a 747 with just 3 engines. From lost blueprints to what-if moments in aviation history, this story has it all. So stay with us till the end because you're about to hear what few people know. Welcome to Airplane Curious. Don't forget to hit that subscribe button if you love aviation stories no one else is telling. In the late 1960s and early 1970s, the skies were getting crowded. Air travel was booming. More people were flying than ever before, and airlines needed aircraft that could carry more passengers, fly longer distances, and land at airports that didn't have long runways. But there was a problem. Back then, safety rules limited how far a 2-engine plane could fly from the nearest airport. If one engine failed, the plane had to land quickly. This rule was known as ETOPS, Extended Range Twin Engine Operational Performance Standards, and it meant that twin jets couldn't fly long routes over oceans or remote areas. So, aircraft makers had a solution: 3 engines. A Trijet could go farther than a twin, but it was cheaper and more efficient than a 4-engine plane. 2 companies led the charge. McDonnell Douglas launched the DC-10. Lockheed answered with the L-1011 TriStar. These sleek, wide-body jets offered airlines the range and safety they needed, and passengers a brand-new flying experience. The Trijet quickly became a symbol of modern air travel, and as the success of these jets grew, Boeing couldn't ignore the trend for long. In the early 1970s, Boeing watched as rivals took over the mid-size wide-body market. Lockheed had launched the L-1011 TriStar, and McDonnell Douglas was already flying the DC-10. Both were sleek, powerful Trijets, and both were eating up airline orders. Boeing had the mighty 747, but it was a giant, built for long-haul routes and high passenger numbers. It didn't quite fit the middle-range demands that airlines were now asking for. Boeing knew it had to act fast, or be left behind. So, engineers began studying new versions of the 747. One concept stood out: the 747-300 Trijet. It would have just 3 engines, not 4. Smaller, lighter, and cheaper to operate than the original jumbo jet. Perfect for medium routes. The design was bold. 2 engines would hang beneath the wings. The third, it would be tucked into the tail using an S-duct, just like the L-1011 and the DC-10. This curved duct allowed air to feed into the center engine smoothly while keeping the fuselage clean and aerodynamic. Boeing saw the potential. The Trijet version could reuse much of the 747 structure, but open up an entirely new market. On paper, it looked like a winner, but reality was more complicated. In the early 1970s, Boeing engineers sat around drawing boards asking a wild question. What if we took the legendary 747 and gave it just 3 engines instead of 4? The idea wasn't just about saving fuel. It was about building a plane that fit nicely in between the giant 747 and smaller jets like the DC-10. A Trijet version of the 747-200 could carry around 300 passengers. It would fly far, handle heavy cargo, and use less fuel than its 4-engine cousin. Boeing explored several designs. One of them removed the number 2 engine, the one under the left wing. That left 1 engine on each wing and a third mounted in the tail, using a clever S-duct design similar to the one found on the Lockheed L-1011. It looked sleek, powerful, and modern. But right away, they hit a wall. The 747's huge wings were built for 4 engines. Removing one changed everything: weight balance, lift, and performance. A whole new wing structure would be needed. That meant more money, more testing, and more delays. And the center engine? That was another headache. Boeing had never designed a rear-mounted engine for a jumbo jet before. The airflow challenges were serious, so was the heat and vibration. It wasn't just about putting an engine in the tail. It was about making it safe at high speeds, high altitudes, and in all weather conditions. Inside Boeing, some engineers believed it could work, but others weren't convinced. A bold idea was slowly turning into a technical nightmare. And still, they weren't ready to give up. Not yet. On paper, a Boeing 747 Trijet sounded brilliant. Fewer engines meant lower fuel consumption and maintenance costs. It could have opened up new, profitable routes for airlines. But as engineers began to turn sketches into something real, the problems started piling up fast. First, the wing design. The original 747's wings were built to carry 4 engines, not 3. To make the Trijet work, Boeing would have had to completely redesign the wing structure. That meant shifting weight distribution, changing fuel tank layouts, and rebalancing the entire airframe. It wasn't just about removing one engine, it was about re-engineering an entire aircraft from the inside out. And that was going to be expensive. Very expensive. Then came the certification headaches. A Trijet configuration introduced new challenges for pilot training. Authorities like the FAA would have required different certification for crews flying a 3-engined widebody. This meant retraining pilots already flying 4-engine 747s, and airlines weren't thrilled about the added time and cost. It was a logistical mess waiting to happen. There was also concern about engine-out scenarios. Where exactly would the third engine go? Mounted in the tail, like the DC-10? That would add complexity. Mounted under the fuselage? That raised safety concerns. No matter what layout Boeing considered, it created new risks and costs. In the end, Boeing made a quieter move. Instead of launching a risky Trijet, they went with a safer option, the 747 SP, a shortened version of the original 747. It had better range, lower capacity, and kept all 4 engines. For Boeing, it was a compromise that made more sense. But still, the Trijet idea never fully died. It lingered in back rooms and sketchbooks waiting for its moment. When Boeing began sketching early ideas for the 777 in the late 1980s, it wasn't certain the aircraft would be a twin-engine jet. Some of the first concepts were Trijets. At the time, long-distance routes were still dominated by aircraft with 3 or 4 engines. ETOPS rules, those that limited how far a twinjet could fly from a diversion airport, were strict. If you wanted to cross oceans safely, airlines needed extra engines for backup. So Boeing considered a 3-engine layout for its new aircraft. One early version was called the 777-100 Trijet. This model had 2 engines under the wings and a third one at the base of the vertical stabilizer, just like the DC-10 or the Lockheed L-1011. It wasn't just a side idea. Some big players, including American Airlines, pushed hard for this design. They wanted a fuel-efficient aircraft that could carry passengers over long distances, but still meet all safety requirements. But things were changing fast. In the mid-1980s, regulators began relaxing the rules around ETOPS. Airlines could now fly twinjets on longer routes, as long as the engines met high safety standards. This was a game changer. It suddenly made twinjets more practical and profitable. As Boeing weighed its options, the benefits of a Trijet started to fade. Trijets were heavier, more complex, and costlier to maintain. Meanwhile, advances in engine technology made 2 engines more than enough to handle the job. So the Trijet version of the 777 quietly disappeared. Boeing locked in the twin-engine configuration, and the rest is history. The 777 would go on to become one of the most successful wide-body jets of all time. But behind its clean design lies a forgotten chapter, one where it almost had 3 engines. By the late 1980s, the skies were changing. Jet engines were becoming more powerful and more reliable, and something called ETOPS, Extended Range Twin Engine Operational Standards, was quietly rewriting the rules of long-haul flying. Before ETOPS, airlines needed 3 or 4 engines for transoceanic routes, just in case one failed. But with ETOPS, regulators began to trust that 2 engines were enough if certain safety standards were met. That shift shook the entire industry. Boeing and Airbus saw where things were headed. Instead of investing in complex trijet designs, they turned toward twin jets, like the Boeing 777 and the Airbus A330. These planes were cheaper to operate, easier to maintain, and could now legally cross oceans without a third engine. Not everyone gave up right away. McDonnell Douglas still believed in the Trijet and launched the MD-11, a stretched, modern version of the DC-10. It had the range, it had the speed, but even that wasn't enough to compete with the efficiency of newer twin-engine planes. Trijets were slowly fading into the background, outpaced by technology and regulation that no longer needed them. Building a trijet isn't just about removing or adding an engine. It's a complex puzzle, especially when it comes to engine placement. Most trijets place one engine on each wing and the third engine at the base of the vertical stabilizer. But getting air to that tail-mounted engine isn't easy. That's where the S-duct comes in. The S-duct is a curved air intake system. It pulls air in from above the fuselage and guides it down into the engine. Sounds simple, but it's not. The airflow has to stay smooth while bending through that tight curve. Any disturbance could affect engine performance or worse.
There is also the weight problem. Supporting a large engine on the tail needs extra structure. That means more materials, more weight, and more stress on the airframe. Compare this to the Boeing 727, which used a similar S-duct design. It worked well because the plane was smaller and lighter. But scaling that system up for a massive jet like the 747, that was a different beast. Engineers faced serious challenges with balance, drag, and efficiency. Boeing realized that the cost of solving these problems might outweigh the benefits. Still, they explored it, right down to wind tunnel testing and internal mock-ups. The 1970s oil shocks hit airlines like a freight blow. In 1973, OPEC's embargo sent crude prices soaring, nearly 300%, from about $3 to $12 per barrel. For airlines, fuel wasn't just another cost. It became the single biggest expense, surpassing even labor in some cases. Pan Am, for instance, saw oil costs at a staggering $200 million in 1974 alone. That kind of financial pressure changed everything. Airlines demanded planes that burned less. Efficiency was no longer a luxury, it was survival. Every drop of fuel wasted meant less money for routes, staff, and growth. Meanwhile, Boeing's Trijet rivals were locked in a fierce battle. McDonnell Douglas rolled out the DC-10 in 1972, beating Lockheed's L-1011 TriStar to market. That early launch gave the DC-10 a head start in sales and service. Lockheed's TriStar boasted cutting-edge tech, advanced hydraulics, S-duct engine, and Autoland systems, but delays in its RB211 engine hurt its launch. Then Airbus crashed the party. In 1974, Europe's Airbus A300 twinjet entered service. Airlines loved the A300's efficiency for medium-range routes. It burned less fuel, needed less maintenance, and was simpler than three-engine jets. This was a turning point. The arrival of the A300 showed that twin-engine planes could handle the same routes without the extra engine cost. Low-cost carriers also entered the fray. Budget airlines in Europe switched to efficient twin jets, squeezing margins for older trijet fleets. Airlines demanded standardization. Same engines, same cockpit layouts, same maintenance needs. Trijets, different engines and extra systems, didn't fit the bill. Even strong players felt it. Braniff, fueled by high hopes in 747 and 727 fleets, collapsed under fuel costs that doubled by 1979. The industry began to see that fewer parts, fewer systems, fewer engines meant less to go wrong and more savings. By the 1980s, extended ETOPS rules allowed twinjets to fly long overwater routes, once reserved for 3 or 4 engines. The Boeing 767 entering service in 1981 nailed the middle market Boeing once eyed for its trijets. Airbus followed with the A310 and later A330 twins for long haul, and the stage was set. The era of the wide-body trijet was winding down, overtaken by efficiency, regulation changes, and fierce market competition. Chapter 9: Legacy and What If. Boeing's failed trijet plans left behind more than just abandoned sketches. They left a clear message about the future of aviation. One of the biggest lessons? 2 engines were enough. As jet engines became more powerful and reliable, airlines began to favor twins over trijets for one simple reason:
Cost. Fewer engines meant less fuel, less maintenance, and fewer chances for things to go wrong. This shift paved the way for one of Boeing's greatest successes, the 777. Originally, even the 777 had a Trijet version on the drawing board, but by the time Boeing moved forward, engine technology and new ETOPS regulations made the Trijet unnecessary. The result? A twin-engine jet that would become a long-haul workhorse for decades. Still, aviation fans can't help but wonder, what if the 747 Trijet had been built? Would it have competed with the DC-10 and L-1011? Could it have changed Boeing's entire wide-body strategy? With today's fuel-efficient engines and strict emission standards, a 747 Trijet might seem like a relic of a past that never happened. Yet, the idea still fascinates, a glimpse into an alternate path Boeing never took. Boeing was never afraid to innovate. The idea of a massive 747 Trijet proves that. It was bold, ambitious, even futuristic. But in the end, it just wasn't practical. The cost of redesigning wings, the complexity of a 3-engine setup, and the changing demands of airlines all led Boeing to walk away, quietly, without ever building a single prototype. Still, those early Trijet plans helped shape the future. They forced Boeing to think smarter, leading to legendary aircraft like the 777, a plane that succeeded by embracing efficiency, not size or extra engines. Aviation has full of what-if stories, and this one is among the most fascinating. If you enjoyed uncovering this hidden chapter in Boeing's history, give this video a like and subscribe to Airplane Curious for more deep dives into untold stories. And let us know in the comments, what forgotten aircraft or concept should we explore next?